Hello, welcome to our electronics presentation. This semester, my partner, Joseph Barty, and I, Marquez Arroyo, made an automatic irrigation system. The way that our project works is you will click on an LCD screen and pick the type of plant that you want to be watered. Depending on that type of plant, there will be a certain range of moisture sensor levels. After that, the moisture sensor will be detecting those levels and turning on a pump if the plant needs to be watered. If the plant does not need to be watered, the pump will not turn on, it will remain off. Unfortunately, due to the coronavirus pandemic, we were not able to complete our full project as we had originally intended. However, we will be finishing our project and presenting it in the fall of 2021. Here is an outline of our original project idea. You can see that we would have had 3 plants, each with its own separate moisture sensor connected to the LCD. Each of the plants would also have its own pump inside of the water tank. The water tank would pump water to each plant when each plant sensed low level. We'd also planned on having a carryable tray for the whole project that would be about 4 feet by 4 feet. Here is our working prototype. You can see instead of having 3 moisture sensors, we started with just the one. And instead of having pumps, we used LEDs to simulate the pumps turning on. Here is a picture of our state machine diagram. After you power on our project, you will go to a choose plant state. And after you press forward, you will be able to pick between either a cactus or a fern using the up and down buttons. After you select your plant, you will go to a pump off state. If in the pump off state and you sense a dry level, you will go to the pump on state, where you will run for a certain amount of time depending on how dry the plant is. After you run that time, you will go back to the pump off state. If while you're in the pump off state, you sense wet, you will stay in the pump off state. If at any time in either the pump off or the pump on, in the cactus or in the fern, you press the left button, you will go back to the choose plant state.
Hi, I'm Joe Barty, and I'll be going over some custom design parts and features, circuit and functionality diagrams, and finally the working video of our project. Here we can see a 3D printed cover for our LCD. This will allow us to make our project look more professional and also give us access to each button. Here's our circuit diagram for our Arduino. On the left is our moisture sensors connected to analog and 5 volts. On the bottom here we have our 3 pump motors, which will be activated by NPN transistors. Each motor will also have a flyback diode. Here we have our LCD circuit diagram. The LCD is directly connected to the Arduino. And here we have our buttons, which are in parallel and separated with a different resistor for each button. So depending on which voltage output it reads, will indicate which button is pressed. Here we have our functionality diagram, which includes our water tank with our 3 pumps leading to 3 different types of plants. And in each plant, we have moisture sensors reading the moisture level in the soil. Our LCD will allow us to input the types of plants. And once 3 plants are inputted, the moisture sensors will begin sensing the moisture level in the soil. And once moisture level is too dry, the LCD will display that the pump is watering that specific plant. So here's our final project. We have our LCD, which is hooked up directly to our Arduino Mega. We have our moisture sensor, which is also hooked up to Arduino. And then we have an LED, which represents a pump turning on and off. And here's our code. which I will upload. It just runs through all the states that Marquez previously mentioned. So in state 1, you get to choose the plant. You go down and you can select whichever type of plant it is. Right now we only have 2 plants that you can select, but we will add more later. So right now we can choose cactus. Go up, press select, and because the moisture sensor is sensing the dryness of the air, the pump or LED should turn on. And the LED will turn off once it runs through the calculated amount of time. So when we put our moisture sensor in water, the pump or LED should not turn on at all because it's sensing that the moisture is at an adequate level or beyond. And if we take it out, dry it off a little bit, it should sense the air again and turn the pump back on to water the plant. And if we serial monitor what the moisture sensor is reading, we see that the moisture level of the air is about 570, and the desired moisture level for the cactus is 500. So that is the reason why the pump is turning on, because it's trying to get the moisture level to the correct desired amount. So if I bring the level down to about 510, the pump should only run for the shortest amount of time, which is about 2 seconds. So we'll see if it does it. Yep, it's about 2 seconds. And if we dip the moisture sensor in the water again, we see that the moisture level is about 310. And anytime during this operation, we can push left and go back to state 1, which is selecting the plants. If we go down to fern, we can select it. This time, let's select it with the moisture sensor in the water. See what happens. So initially, the pump doesn't turn on because it's sensing that the moisture level is more than adequate. And if we raise the moisture sensor out of the water, the pump should eventually turn on. And because typically ferns require more water, the pump on time is a little bit longer than what the cactus's pump on time is. The pump on time for the fern is about 6.5 seconds, while the pump on time for the cactus was only about 4.5 seconds. And once again, if we bring this moisture level down to its desired around 400, the pump should only turn on for about 2 seconds. So again, that's about 400. Yep, that was 2 seconds. And that concludes the video for our working project. Thanks for watching.
While we were definitely happy with our project in its original concept and in its current state, there were some improvements that could have been made. Mainly, we could have bought better pumps, made our project look more professional, and added additional sensors and pumps to make it for a bigger application. However, our overall experience of the project was a positive one. There were some difficulties with the coronavirus shutdown of our campus, but we were still able to practice and solidify all concepts that we learned, both in lecture and in lab. We also learned that our project is fundamentally sound, but could be improved upon and expanded for bigger applications. With that being said, we would like to give some special thanks to Dr. Cheng Su for helping us through our project in these difficult times and while we were still working on campus. And we'd also like to give a shout out to the school for the funding for this project.